Good morning, everybody, and welcome to my lectures once more. And today, we shall be treating some other aspects of uh, number-based system. In our last lesson, we treated addition as one of the arithmetic operations. Today, we shall be treating subtraction. You have seen that as we have been doing over the years, we have been doing addition in base 10. In our last lesson, we saw that we can as well do addition in other bases. Today, we are going to look at doing subtraction in other bases. But as usual, we shall begin with base 10, the one we are familiar with, the one we have been doing over the years. We use it to form a foundation or base for understanding what we can do in other bases. So we begin with a subtraction in base 10. So let us do the following subtraction in base 10 ordinary. 675 minus 599. Want to subtract 9 from 5? It is not possible. So you go to 7 and borrow 1. And the one you are borrowing is one bundle of 10. Because you are operating in base 10. So the one you are borrowing from 7 is one bundle of 10. That 10 now you add to 5 to get 15. Now you can subtract 9 from 15. And when you do, what do you get? 6. When you subtract 9 from 15, you get 6. Here you have 6 as a remainder after borrowing 1 from 7. 9 taken from 6 is not possible. So you go back again to borrow another bundle of 10. So you go to 6 and borrow 1. The one you are borrowing is one bundle of 10 because you are working in base 10. So that 10 now plus the 6, you have that there, you get 16. 9 from 16 will give you 7. What is left here is 5 after borrowing 1. 5 from 5, 0. So this subtraction gives you 76. And you have seen how we carried out the subtraction. Now, let us visit other bases, bearing in mind all that we did in base 10. We can also subtract in other bases. Now, let us do the following subtractions. In base 10, in base 8. In base 8, we want to subtract 72 from 643. Of course, that reminds me of what I told you in our last lesson, that in every base, any number in any base cannot contain any digit that is equal to the base or greater than the base. I want to repeat that because that is a mistake some of us make. In any given base, any number in any given base does not contain any digit that is equal to or greater than the base. I explained this in our last lesson. If you are considering base 10, the digits you can get in any number in base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you are operating in base 8, the digits you can get in any number in base 8 are 0, 1, 2, 3, 4, 5, 6, 7. If you are operating in base 6, the digits you can get in any number in base 6 are 0, 1, 2, 3, 4, 5. In base 4, any number in base 4 cannot contain any digit that is equal to or above 4. You can only get 0 in base 4. Any number can only carry the following digits: 0, 1, 2, 3. In base 2, any number in base 2 can carry 0 and 1. 0 and 1. No number in base 2 can carry 2, 3, 4, and so on and so forth. Any number in base 2 contains 0 and 1. 0 and 1 are the digits that can be carried or contained in any number in base 2. Now, having explained that, we come back to our subtraction. In base 8, we want to subtract 7, 2 from 6, 4, 3. Now, 2 from 3 gives you 1. There's no problem with that. 7 from 4, not possible. So what do? You go back to 6 and borrow 1. The one you are borrowing is one bundle of 8 because you are working in base 8. So don't make the mistake of taking your mind back to base 10. The one you borrow from 6 represents 8. So 8 plus 4 will give you 12. Now 7 from 12 will give you 5. Subtract 7 from 12. You get 5. 5 was left here. You bring it down. So if you subtract 7, 2 from 6, 4, 3 in base 8, you will get 5, 5, 1. In base 6, we have to subtract 5, 3, 2, 4 from 4, 3, 2, 1, 1. Again, now we know that we are operating in base 6. 4 from 1 is not possible. You go back and borrow 1. The one you are borrowing represents 6. One bundle of 6. 6 plus 1 will give you 7. 4 from 7, 3. You have borrowed this one, so 0 is left there. 2 from 0 is not possible. You go back and borrow 1. The one you are borrowing is one bundle of 6. 2 from 6 gives you 4. You have 1 left there. 3 from 1 is not possible. You go back and borrow 1. The one you are borrowing represents 6. 6 plus the 1 left here gives you 7. And 3 from 7 gives you 4. 2 is left here. 5 from 2 is not possible. You go back and borrow 1. The one you are borrowing represents 6. The 6 plus 2 now gives you 8. 5 from 8, 3. 3 is left here. You bring it down. So if you subtract 5, 3, 2, 4 from 4, 3, 2, 1, 1, the result is 3, 3, 4, 4, 3. Now go over to base 4. You can see that we are extending our idea. Our idea has come to a point now where we understand what we are doing. In base 4, we have to subtract 2, 3, 1, 1 from 1, 0, 2, 1, 1. 1 from 1, 0. 1 from 1, 0. 3 from 2, not possible. You cannot borrow from 0. You have to go back and borrow 1. The one you are borrowing is 2. The one you are borrowing is what? 2. So you put the 2 here. Sorry. Okay, okay. You put the 2 here, and then from that 2, you borrow 1. The one you borrow now is one bundle of 4. You know, that one bundle of 4, add 2 to it, you get 4 plus 2, you get 6. Then 3 from 6 gives you this 3. Sorry, I think I made a mistake somewhere. The one you borrowed here, please, represents 4. The one you borrowed from here, the one you are borrowing, is 4 because you are working in base 4. So from that 4 now, you have borrowed 1, which represents 4 again. The 4 plus 2 gives you 6. 3 from 6, 3. 3 is left here. 2 from 3, 1. So this is how you get 1300 by subtracting 2311 from 10211. I hope it is understood. Then in base 2 or binary, we are to subtract 101 from 1110. See how we do it. 1 from 0 is not possible. So you go back and roll this 1, which represents 2. Represents 2. From the 2 down, you borrow 1, which again represents 2. And put it here. 1 from 2 gives you 1. 1, okay, 0 is here because you have already borrowed this 1. You borrow this 1, which represents 2. And you put that 2 here. 1 from 2, 1. 0 is left here. 0 from 0, 0. 1 from 1, 0. Then you bring down this 1. Let's take it again. 1 from 0, not possible. You go back and borrow this 1, which represents 2. It represents 2 because you are working in base 2. So 2 comes here now. 1 from 2, 1. 0 is left here after borrowing this 1. 0 from 0, 0. 1 from 1, 0. You bring down this 1. And so we shall conclude this part of our work on a number-based system. In our next lesson, we shall treat multiplication in the various bases. God bless you.